Example 6. This example will show you how to do partial differentiation for a function that depends more than two variables. For example, we are given f of x, y, z, which is equal to x cubed y squared z power 4 plus 2xy plus z. So this function depends on three variables. Part A. Find the partial differentiation of f with respect to x. Since the function f has three terms, so this is equal to partial differentiation with respect to x applied to x cubed y squared z power 4 plus the partial differentiation with respect to x 2xy plus the partial differentiation with respect to x z. Remember, when you do the partial differentiation with respect to x, you treat the other independent variable as constant. That means you treat y, z as constant. So they are fixed. So when I do the first partial differentiation, your y squared is a constant, z4 is a constant, so they are constant factor. So you only differentiate x power 3 with respect to x. For the second term, 2y is a constant factor, so differentiate x with respect to x. And the last term is 0 now, since z is treated as constant. Differentiate x cubed with respect to x, you get 3x squared, and differentiate x with respect to x, you get 1. Therefore, the final expression is 3x squared y squared z power 4 plus 2y for the partial differentiation of f with respect to x. Part B. Find the partial differentiation of f with respect to y. Since the function is a sum of three terms, so this is the sum of partial differentiation with respect to y on x cubed y squared z power 4 plus the partial differentiation with respect to y on 2xy plus the partial differentiation with respect to y on z. Notice that as we do partial differentiation with respect to y, you treat the other independent variable x and z as constant. That means they are kept fixed. So the first term, x cubed z power 4 is a constant factor, and we differentiate y squared with respect to y. For the second term, 2x is a constant factor, and we differentiate y with respect to y. And the third term is 0, since z is constant. Differentiate with respect to y, you get 0. And differentiate y squared with respect to y, I have 2y. Differentiate y with respect to y, you get 1. So the final answer is 2x cubed y z power 4 plus 2x for the partial differentiation of f with respect to y. For part C, we are going to do partial differentiation of f with respect to z, where f is the sum of three terms, which is x cubed y squared z power 4 plus 2xy plus z. So partial differentiation of f with respect to z is differentiate the first term with respect to z, differentiate the second term with respect to z, and differentiate the third term with respect to z. Now, when you do partial differentiation with respect to z, you treat x, y constant. So the first term, x cubed y squared, is a constant factor, and you differentiate z power 4 with respect to z. For the second term, you get 0, since 2xy is a constant, and you differentiate with respect to z. The third term, you get 1, since differentiate z with respect to z, you get 1. Therefore, partial differentiation of f with respect to z is x cubed y squared times 4z cubed, then plus 1, or 4x cubed y squared z cubed plus 1. So the answer for partial differentiation of f with respect to z is 4x cubed y squared z cubed plus 1. Now for x equal to negative 1, y equal to 1, z equal to 2, I get 4 times minus 1 power 3, 1 power 2, 2 power 3 plus 1, which is equal to negative 32 plus 1, which is negative 31.